What if you could assemble a team of AI agents as easily as dragging and dropping nodes on a canvas? And what if that entire platform could be built in just 24 hours? Hey everyone, today I'm sharing something incredible we built at the YC Agents Hackathon in San Francisco. In just one day, our team created Tzelem, a dynamic multi-agent orchestration platform that lets you build AI teams that actually ship real work. And here's the best part. We're releasing everything as free and open source under the MIT license. What we built. So what exactly is Tzelem? Think of it as a conductor for an orchestra of AI agents. You define your goal and set a budget, then Tzelem assembles specialized agents, coordinates their workflows, and delivers results, all with complete observability, auditability, and budget guardrails built in. During the hackathon, we focused on creating an end-to-end experience. You can design agent workflows visually using a drag-and-drop interface. Start a run with a single click, watch live status updates stream in real time, and even spin up voice channels so your agents can literally call you and ask for feedback or approvals. The entire codebase is organized as a clean monorepo. We've got a modern front end built with Vite, React 19, and TypeScript that ships a polished flow builder UI. The backend runs on fast API and handles everything from workflow orchestration to WebRTC room creation. And we even squeezed in time to build a landing page for demos. All the links and resources are in the description below, including the GitHub repository where you can grab the code right now. High-level architecture overview. Let me walk you through the architecture because the choices we made here are what allowed us to ship something this complex in just 24 hours. The front end is built on Vite with React 19 and TypeScript. For the flow builder, which is really the heart of the user experience, we used React Flow to model and connect agent nodes. We leveraged ShadCN and Radix UI components to get a clean, accessible design out of the box. Tailwind handles our styling with CSS variables for theming, and Lucid provides all our icons. Everything's bundled with code splitting and lazy loading to keep that first paint lightning fast. On the back end, we went with Fast API running on UVcorn. This lightweight API powers voice room creation and manages the flow and run lifecycle. Here's where it gets interesting. We use server sent events, or SSE, to simulate live progress updates. This gives users that real-time feel without having to build a full orchestrator in 24 hours. All our endpoints live under a clean API structure, and we centralized configuration using Pydantic settings to read environment variables securely. For voice and WebRTC capabilities, we integrated daily.co through Pipecat. The key insight here was to create rooms and ephemeral join tokens entirely server-side. This means API secrets never touch the client, a crucial security consideration that many hackathon projects overlook. Backend deep dive. Now let's dive deeper into the backend because this is where a lot of the magic happens. The main application file sets up FastAPI with proper CORS configuration for local development. We include routers for flows, runs, and voice endpoints, expose health checks, and log structured startup and shutdown messages. One nice benefit of FastAPI is that you get Swagger documentation and redoc completely free. Super helpful when other team members need to integrate with your API. For configuration, we use Pydantic settings with .env to load environment variables like debug flags and API keys from a single env file at the repository root. This centralizes all our environment behavior and keeps secrets completely out of the code. The voice integration is particularly elegant. We have a simple post endpoint that returns a room URL and join token. Behind the scenes, we're using Pipecat's daily rest helper to create the room and generate a 1-hour ephemeral token. In debug mode, we log a safe preview of the token without exposing the full secret, a small detail that prevents accidental credential leaks during development. For flows and runs, we built stub endpoints during the hackathon that return realistic data. The flows endpoint stores and fetches flow.json that matches our front end's export format exactly. The runs endpoint is where things get really interesting. It provides a streaming server sent events endpoint that yields realistic lifecycle events. Run started, node started and completed, progress updates, and run completed. This unblocked our front-end team to build the entire live UX without waiting for a full orchestrator implementation. We didn't skip on quality either. The test suite mocks external services properly, exercises all endpoints end-to-end, and verifies both success and error paths. The CI pipeline runs linting with Rough, type checking with MyPy, and the full PyTest suite. We use UV for Python dependency management, which gave us incredibly fast cached installs, a huge time saver during rapid iteration. Front-end deep dive. The front end is where users actually experience the magic, so we invested heavily in making it feel professional despite the time constraints. The app shell uses Vite with React 19 and TypeScript. We lazy load the flow builder component using React's lazy and suspense APIs to minimize the initial bundle cost. Error boundaries and loading spinners ensure a resilient user experience even when things go wrong. The flow builder itself is the star of the show. We defined custom node components for different agent types. Master agent for orchestration, execution, agent for tasks, routing agent for decision-making, data collection, agent for gathering information, and mail agent for communication. Each has its own visual design and configuration requirements. The node palette provides drag-and-drop creation with a glossy, accessible UI. When you drop a node, we automatically check for overlaps and nudge the position to find the nearest open slot. This gives you that crisp, predictable layout that makes the tool feel professional. We use visual grammar to make orchestration semantics obvious. Agentic edges are animated in blue, while sequential edges render as dashed lines. The canvas includes a dotted background, zoom controls, and a mini-map with state-aware coloring that highlights selected nodes and validation errors. For state management, we implemented a use reducer with context pattern. Every mutation snapshot state into a bounded history, capped at 50 to prevent memory issues, enabling robust undo and redo with constant time operations. We added global keyboard shortcuts for all the operations power users expect: undo, redo, delete, escape, and placeholders for future command palette integration. Validation runs on every change, enforcing domain rules for each node type. Master agents require a model and system prompt. Routing agents need at least one class and a model. Data collection agents require a schema, and mail agents need sender information. We also detect orphan nodes that aren't connected to the graph. All validation errors appear inline and control whether the Run Workflow button is enabled. Novel problems and fast solutions. Building something this complex in 24 hours required creative solutions to several challenging problems. First, we needed real-time UX without building a full orchestrator. Our solution was to implement that SSE stream I mentioned earlier, emitting a realistic event sequence that let us build the entire live console experience while the actual orchestration engine could be developed later. For voice credentials, we needed zero-leak security by putting daily room creation behind a server endpoint and returning only ephemeral tokens. We ensured the API key never leaves the server. The debug mode logging only shows truncated previews, enough to verify things are working without risking accidental exposure. The collision-free node placement seems simple but makes a huge difference in user experience. Our drag-drop logic iteratively checks positions and offsets new nodes to avoid overlaps. This gives the flow builder that professional feel without needing a complex auto layout engine. Validation that actually helps users was crucial. We encoded specific domain rules per node type and flag orphaned nodes. This prevents the frustrating experience of thinking you've built a working flow only to hit an opaque failure at runtime. For undo and redo, we needed something fast and memory safe. Bounded snapshots with simple array operations made it trivial to implement keyboard shortcuts without bogging down React with expensive deep object comparisons. On the development experience side, using UV for Python package management shaved minutes off cold installs, and pinning node version 24.6.0 ensured compatibility with React 19 and the latest ecosystem libraries, letting us use modern features confidently. What's next in wrap-up? So where do we go from here? The foundation we built in 24 hours is remarkably solid, but there's exciting work ahead. First, we'll wire up the Run Workflow button to actually execute flows, connecting the SSE stream to a proper run console with timeline visualization, active node highlighting, cost metering, and full transcripts. The voice UI needs to be completed with full Pipecat client integration, including robust token lifecycle management. We'll add persistence with a proper database, implement authentication and team features, and build out the mail delivery system. Policy and budget guardrails need to expand beyond the schema into runtime enforcement. And of course, we need to dog food the system with real workflows to tighten up the event taxonomy and user experience. This was just 24 hours of building, but we've created something special: a typed flow schema, real-time streaming scaffolding, secure voice tokenization, and a frictionless UI for assembling agent teams. And remember, it's all free and open source under the MIT license. You can use it, fork it, break it, improve it, whatever you need. Check the description for links to the GitHub repository and hackathon context. If you want to dive deeper or contribute to the project, we'd love to hear from you. Tzelem, building AI agents in your image, delivering outcomes on your budget. Thanks for watching and happy building.